So you guys enjoying the conference so far? Have you seen some good talks? Yep. You'll have to nod louder because I can't hear you nodding. Yeah. Okay, have you seen any bad talks? No? Okay, put your hands up if you've seen a bad talk. Right, were you in my session earlier? No? Excellent. Good. You can stay then in that case. Were you in my session earlier? Did you put your hand up for the fact you've seen a bad talk? Yeah. Oh, really? Okay, I make that 10 past, so we're just going to get started because we've got quite a lot to get through in the time. So we'll just crack on. This is an introduction. This is me, Gary Short. I'm a technical evangelist for DevExpress. Okay, I'm a C# MVP. You can get me an email address here. This is my blog, and this is my Twitter address. Who's on Twitter here? Okay, who actually uses it to talk to people? Excellent, right? So you can get me on Twitter there. Please feel free to add me. Send me any questions that you've got. Email me your questions if you don't get them answered at the end or you don't have time to catch up later on. Okay, you're always guaranteed to get an answer from me if you tweet. Sometimes not so much if you send an email. The reason for that is if you contact me on Twitter, your question can only be 140 characters long. All right, far more likely to get an answer from either a short question like that. You may not like the answer, but you'll get an answer. All right, guys, no worries. Just come in, grab a seat. We were just killing time till you guys arrived, don't worry. Okay, there's a few seats over here up at the back if you guys don't want to sit on the stairs. You don't like to see the person over there smells? No. Which one? Point them out to me. Okay, good stuff. Right, let's crack on. So that's me. What about you guys? Who here has heard of NoSQL databases before? Hands up. Okay, a few of you. Good. Who's used a NoSQL database? Who's used a NoSQL database in anger? Yes. By the way, that's the only way to use a NoSQL database. All right. So a few of you have used NoSQL before. Excellent. A few of you have heard of NoSQL. The majority of you are either really shy or have never heard of NoSQL before. Okay? We're not too sure which it is, but we will find out. So what we're going to do in this session is we're going to take a breadth-first look at NoSQL, right? So we're going to cover a lot of information. We're not going to cover huge amounts of depth, all right? So in this session, I'm not going to pick a NoSQL database and really go into depth with it. I'm going to give you a lot of breadth information about NoSQL databases in general. But towards the end, we are going to get really deep in towards the one application of NoSQL databases in the real world, okay? Just to show you that this is not just a pipe dream. Okay? Just to show you that people are actually using it. But in general, not particularly deep, but really breadth. All right? We're going to be doing three things, in fact. Okay? We're going to be defining NoSQL databases so that everybody knows what they are. All right? In your head, you probably have a good idea of what a NoSQL database is. All right? But I'm going to show you exactly what it is, and it will probably broaden your horizons, and you'll realize that some things that maybe you didn't think were NoSQL databases actually are when you start to look at them. Okay? Second thing we're going to do is we're going to look at some scenarios where you would use NoSQL databases, some scenarios where you would use a traditional database, okay? And just so you can tell the kinds of differences, and you can pick up quickly the scenarios where you think to yourself, do you know what, actually, I should be using, or I could be using a NoSQL database here, all right? Before we go any further, though, just while some other people are grabbing seats and stuff like that, before we go on any further, something I should have mentioned at the start and I completely forgot. You people might have noticed that I speak a bit funny. Right? Okay, that's because I'm from Scotland in the UK. I also happen to speak really fast, especially when I get going and I get excited. Right? So if you find that I'm speaking too fast, and because of the fact that I'm speaking too fast and I've got a really dumb accent that you can't actually understand a word I'm saying, right? Please don't let me ramble on to the end. And then when I say, does anybody have any questions? Say, yeah, do you know what? I never actually understood a word you said after hello, my name is Gary Short. All right? Try not to do that because by that time it's too late. All right? Put your hand up and just say, slow down a bit. Okay? But I'll try not to speak too fast. So that's the second thing we're going to do. Third thing we're going to do is we're going to drill into a specific use case, like I said, all right? So I'm actually going to demonstrate to you that NoSQL is not just a pipe dream. There are people using it. For those of you who are frantically scribbling down notes, Please feel free to do so if you want. If you find it's easier to take stuff in because you're writing it down, then please carry on doing that. But don't feel you have to take notes. The slide deck are going to be made available by the conference organizers. All right, so you're going to be able to download them from some point in the future. I just say you'll be made aware of that. All right, so everything you see here, you're actually going to get this slide deck. All right, so don't feel that you have to take notes if you don't want to. Okay, so before we can talk about NoSQL databases, let's talk about where we were, where we came from, and why we had NoSQL databases. So in the beginning, we didn't really have any kind of database or any structure. We used big lumps of data, normally in text, and we shifted them around a lot. We found out that that wasn't very proficient. So around about the late 60s, the early 70s, we came up with, I say we, right, it wasn't me because I was just a baby then, all right? I paid no part in this, right? We came up with, as an industry, the relational database model. Who's heard of the relational database model? Excellent, everybody practically, all right? And that is, by and large, what we mean when we say database, right? When we say database, we really mean a subset of all databases that are really relational database management systems, all right? Can anybody tell me what problem the relational database model solved? That's one of the things, yeah, it's one of the things it does. It maintains referential integrity. But the problem of the day, the problem that they were trying to solve was data duplication. All right? The rules of normalization are there for pretty much one reason, or one main reason, and that is to remove duplicate information. And that is because the main problem they were trying to solve at that day was the fact that storage media was expensive, right? Megabytes, gigabytes, and terabytes were hugely expensive back in the 70s. And so the relational database model came along to say, this is how we're going to fix that problem. This is how you can store data in the most efficient manner that you can so that you don't have to buy more storage, okay? Now, here's a question. Who of you who are working engineers in the software industry today, who has the main problem that they're trying to solve, one of, I don't have enough storage? Right? Just one. Buy some more. Okay? The thing is, there's always one. Yeah? Okay? Buy more. The thing is, it's cheap. All right? Especially if you're buying it in bulk. All right? Gigabytes are cheap. Yes, so you have a question already.
So it was also solving the problem of maintaining data correctly. So if I have a customer and the name is changed in one place,
yep.
Probably it helps also update.
Yes. Easy for me to say. Referential integrity. Yeah, absolutely. So it does that as well. You're absolutely right. So it solves more than one problem, and I'm not trying to pretend that it only solved one thing. Okay? But the main problem we're trying to solve is to get away with data duplication. And the point I'm trying to make today is very few people have the fact that storage is expensive as a problem they're trying to solve. All right? That problem is pretty much solved. Okay? Disk space storage is relatively cheap. I mean, you can go and buy a SAN and it can cost thousands and thousands of dollars, right? So it's still expensive. But compared to what the same amount of storage would have cost you back in the early 70s, all right, it's practically giving them away, all right? So nobody really, apart from this gentleman here, all right, everybody take note, right? Everybody look at him now and make him feel silly, all right? Apart from this gentleman, nobody really has that as a problem anymore. And as in the industry in general, we don't. That is not the problem that we're trying to solve now, okay? And yet, we're all still using the relational database as if it is the problem. One of the main problems that we're trying to deal with today is the sheer volume of data. Okay, if you look at the billion-dollar companies, the new billion-dollar companies that are in the marketplace just now, the likes of Twitter and Facebook and Google, the people who have come along in the last decade, okay, their problems are not one of data storage. Their problem is one of handling the vast amounts of data that they're handling at web scale. Okay, and that's really one of the main problems that they're dealing with today. I'm not trying to pretend it's the only one. Okay, what I'm trying to say is that it's definitely a problem that we have to deal with, and it is different from the problem that the database that we're mainly using just now was actually designed to solve. Okay, so let's have a look at where the NoSQL originated from. So back in 1989, right, when I was just a small boy, why are you laughing? I see you laughing, right? That wasn't a joke, right? How mean is that? Okay, so there was an open source relational database, Okay, it was created by this chap here, and it didn't expose a SQL interface at all. Okay, so there was no. So everybody understands that for relational database systems, the majority of them, SQL is the language that you use to query them and communicate with them. Okay, well, this particular database, it didn't use SQL. All right, and they called it NoSQL, because the guy was really imaginative. All right, there was no SQL, so we called it NoSQL. All right. However, and this is the important thing, really, the author said it departs from the relational model altogether. Didn't use the relational model altogether. And he said a fairer name is he should have called it no-rel. Okay, so it's not relative as opposed to NoSQL. Because the NoSQL part wasn't really the important bit. Right? He could just as easily have exposed a SQL interface but not had a relational model underneath. Okay, and it still would have achieved what it wanted to achieve. The important bit wasn't the fact that there was no SQL. The important bit was there was no relational model there. Okay, who's heard of that database? Absolutely nobody. Good, me neither, because it promptly disappeared. All right, nobody ever used it. The idea didn't catch on, and it died. And along with it, so did the name for a few years. But more recently, Eric Evans reintroduced the term back in 2009. I say back in 2009. It's only 3 years ago. All right, so it's a relatively young industry. So back in 2009, himself and this guy here, they wanted an event to discuss open source distributed databases. Okay, they wanted this because all of the labels growing number of data stores. So these ones, these NoSQL databases, they tend to be open source. All right, they're not all. They tend to be non-relational. Again, not all of them are. They tend to be distributed, and they often don't guarantee the ACID principles from RDBMSs. So in Atlanta in 2009. They had a NoSQL East conference, right? I like the fact it said NoSQL East in brackets. There was no North, South, or West. So why they felt the need to call it NoSQL East, I have no idea, right? Maybe they just had delusions of grandeur. However, that's what it was called. There was a conference there. And it was billed as the conference of non-relational data stores, okay? It had the worst tagline ever, okay? So, bear in mind that it's been billed as a conference of no relational data stores, most of them using NoSQL, most of them having NoSQL API whatsoever. Their tagline was, select fun and profit from the real world where relation equals false, all right? The irony of that, the irony of having a piece of SQL, right, as your tagline for a NoSQL event, I thought was hilarious, but was completely lost on the Americans, all right? Who knew? Before we go on, let's just burst an orthodoxy. So there's an orthodoxy that says NoSQL is anti-relational database management system, right? It's NoSQL. It's don't use SQL at all, right? No SQL whatsoever. Now I think that comes about actually because it's easier to be against something. If you want to start a movement and get a lot of people behind you, okay, it's easier to be against something than for something. You know, if you're like, hey, I'm for ice cream on a Sunday, everybody follow me if you want. It's like, I don't really care. Right? If you say, follow me and I'll make sure you don't pay any tax at all ever, right, because I'm against taxes, you're far more likely to be able to drum up support if you've actually got something you're against. And perhaps when they started, they were actually against relational database models and against SQL, okay? But now, the industry has grown up, it's 3 years old now, okay, which is like a grandfather in software engineering, okay? And we've come to realize that these people have to play in the real world. And in the real world, relational databases exist. And we have to play nice, all right? So now the movement is getting away from this idea of NoSQL, meaning actually NoSQL. And they say, well, actually, it means now not only SQL. So the no in NoSQL is not only. And we'll see a brilliant example of that later on, all right? So we're not saying don't use SQL and don't use relational database models. What we're saying is, it's not the answer to everything. And in a scenario where it's not the answer, then don't be afraid to use something else. Okay, don't be afraid to use not only SQL. All right? So let's clear that up straight away. Right, so let's talk about what they look like. Okay? So the key attributes of NoSQL databases are, and we need to crack on because we're running a bit slow. They don't require fixed table schemas. All right, so you know in relational databases like SQL Server, you have to define the schema, and every row that goes into that table has to conform to that schema. All right. Now, some of the columns may have a null value. All right, but they have to have them in some description. All right. NoSQL databases tend to not require fixed table schemas. All right, which means that each row, not that we have rows, but if there were a row, it wouldn't have to be the same as the one above it or the one below it. Okay, they can all be slightly different. All right, and we'll see why that's important later on. All right? They are in general non-relational, all right, but not always. They usually avoid join operations. Somebody tell me why they avoid join operations normally? Because they want to avoid joins because joins are expensive, right? Single most expensive thing that you can do in a SQL query is to do lots of joins, all right? So let's solve that problem by not doing joins. Bearing in mind, the joins are only there because we don't want data replication. So we only store the customer once, and so we have to point to it. And so if we want it, we have to make a join to the table where we keep it. But if we've done away with that and we say, well, we don't care about data replication, we'll have that customer in lots and lots of different places, okay, we no longer have to do the joins because that customer is actually where we need it, all right? So we get a performance saving there. They scale horizontally, all right? What scale horizontally means is we add more nodes to a storage system, all right? There's two ways to scale. You can scale up or vertically, you can scale out or horizontally. Okay, scaling up means you buy more hardware, right? You put in a bigger, faster disk, you put in more RAM, you put in bigger and faster processors, that kind of thing. That's scaling up. Two disadvantages to that. One, it's expensive, all right? Faster chips are more expensive than slower chips, and you can only go so far. Once you've put in as much RAM as that machine will hold, that's it. You can't scale vertically any further. All right? Scaling horizontally instead says, do you know what we're going to do? Instead of scaling up and having a really expensive thing, we'll have lots and lots of small, inexpensive things. Okay? And we'll use that. And that is scaling out the way. All right? So, what does the taxonomy of NoSQL databases look like? What are the classes? How many are there, and what do they look like? All right? Well, they look kind of like this. First of all, in the NoSQL database world, there is a document store, right? So document store are things like this: RavenDB, Apache Jackrabbit, CouchDB, all these kind of things, okay, which actually store documents, all right? Who's heard of any of these? Wait, beg your pardon? MongoDB, right? So is that the one that most of you use? Yeah, who's used CouchDB? All right, who's used RavenDB in the .NET world? All right, so you're mostly Mongo people. All right. All right, why is that funny? I hope I haven't just insulted somebody there. All right, so you're mostly people who use the MongoDB. Is that a better way of putting it, is it? Okay, so document what do we actually mean when we say document storage? Well, let's have a think about this. Let's say we wanted to store a web page. Okay, if we were to use a standard relational database model, okay, where we broke things down like this. So here's our web page, and we're going to store heads and bodies, and under the head there's these kind of tags that would be related, and under body you could have all of those kind of tags going down, all related together. What would be the most common data type stored in that database if you stored a whole load of pages? What would be the most common data type? String, do you think? Who thinks string? Put your hands up if you think string. Right. What happens if you think something else? The thing that you would store most often if you had a database like that is null. Right? Mostly your database would be empty because there's no web page on the planet, okay, that uses every HTML tag. But yet you would have to have a space for every HTML tag because some page will use that tag, okay? And so because we've already said we've got fixed schemas, if we use a fixed schema, every page has to be able to have these things, if one of them does, all right? So mostly, you would have nulls, all right? So that's what a document does. So let's go back a little bit. But what document storage lets you do is to say, do you know what, we're not going to have fixed docs. I'm just going to take the document and I'm going to store that document as it is, all right? So this web page could be different from this web page, which could be different from this web page, and I don't care that they're not all the same. They are all some form of web pages, and I'm going to store them all. Okay? And that way, you're only actually storing real data that you need to store. Okay? You're not storing nulls. All right? So that's what we mean by document stores. So graph storage. Graph storage is another form of NoSQL database. Okay? There are things like Trinity, which is a brand new one from Microsoft. I have no idea whether there's only advancing one at a time. Let's get rid of that. There we go. Okay, so we have all of these graph storage. Who's heard of any of these databases? Put your hands up if you've heard of any kind of graph storage. Nope. Yes. Chap at the end there. Excellent. So, what does graph storage mean? So, a graph consists of, if we remember our maths from school, a graph consists of nodes, or as we tell our children, you know, these will be the stations, okay, on the railway line, and they consist of edges, and that will be the tracks between the railway stations, all right? So that's what a graph is. FlockDB is an example of a graph storage database, and it was created by the good people at Twitter, and we're going to have a good look at that later on, okay? But in that particular instance, then the nodes would be the users, okay? And the edges would be the nature of the relationships between the users, okay? So that's a graph. Social graph, there's a good example of a social graph. So all these little circles are the nodes, and the lines are the edges, and they describe the nature of the relationship between the nodes. There's also key value stores. Okay, key value stores can be stored on disk or cached in RAM. They are eventually consistent. Okay, eventually consistent is a brilliant term. All right, so you know how relational databases are consistent. Okay, they move from a state of consistency. You then have a state of flux where they're updated or changed or have rows deleted or added or whatever, and then they move to another state of consistency. Okay, and then during that state of flux, right, that row, that record, or maybe even that page, depending on what you're doing, is locked out and nobody else can see it. All right? So the only time that it's globally visible is during the stable phases, all right, where they are consistent. NoSQL databases are not the same as that. Okay, they are eventually consistent. So here is a weak definition of eventually consistent. What it says is, if no updates occur for a period, okay, then eventually all of the nodes, every change propagates through all of the nodes on the system. Now remember, we already said we're looking to be able to scale horizontally because that's cheaper. All right, so we've got lots of nodes carrying our data. All right, what the weak definition for eventual consistency says, for every given update at some point in time, we will eventually, all of the nodes will have it. All right. Now that is pretty weak, and for some circumstances it's fine. For other circumstances, it's not good. So we have a stronger definition for the occasions where that is not going to work. Okay, and the stronger definition says, for any given update, for any given update and a given replica, eventually the update reaches the replica, or that replica is retired. Right? And that's the stronger thing. We actually want an action. Right? At a given point in time, if the update has not reached that replica because it's fallen off the net or whatever, for whatever reason, then that replica is going to be retired until the data gets there. So that's a much stronger definition. Okay? Does everybody see the difference between these two definitions? Yeah? Sometimes it can take quite a while to get through your head. Right? Maybe that's just me, because I'm a bit dumb, to be honest. It took me a couple of goes of reading that before I understood it. Okay? They are generally ordered, and a distributed hash table allows lexicographical processing. That's a brilliant phrase, right? It just means in alphabetical order. I don't know why they say lexicographical processing, right? But that's basically what it means, in alphabetical order. There are object databases. Now, this is where I said, this is the extension where I said I'm going to extend the definition of NoSQL probably past where you actually realized there were NoSQL databases. And the reason that I'm going to mention object databases like these, Gemstone and all the rest of it, is they have been around for years. All right? I first started programming commercially back in 1990, and I started programming on Smalltalk, okay, and we used Gemstone as our database, okay? It is a NoSQL database because it doesn't store things in a relational model. It actually physically stores the object. You give it an object graph, it writes that to memory, you read that object graph back out again, okay? But we had this back in the early 90s, okay? So the idea of NoSQL databases is not a new one. All right? It's popular now, and it's been extended to include document databases and graph databases and things like that. But the idea of NoSQL databases, or databases which are not relational in nature, has been around for years. Does anybody here program in Smalltalk ever? I always ask just out of interest because it saddens me. Look at that. Everybody look around. How sad is that? Yeah. Anybody use the Gemstone database? Your hands up. See everybody look around. How sad. You see? The programming language that I learned to program on, nobody uses it anymore. Right? Yeah. Yeah, that's close, right? All of you who laughed, put your hands up if you laughed when I said the programming language that I learned to program on, right, doesn't exist anymore. Doesn't use. Put your hand up if you laughed. All right. Put your hands up if you're a VB programmer. Nah, not laughing now, right? All right. Now here's a question: how on earth? That's what that says. How on earth, right? Do you index that, all right? It's all very well saying, oh yeah, the relational database is easy to index, okay? I mean, it's obvious. Every table has a unique identifier, okay, of one property, or sometimes if you're really mean to your developers, right, you've got composite keys, all right? But it's easy to create indexes because every row in a table is the same. How on earth do you index something like that if everything's completely different? If you're using a document database, right, and the schema, there's no fixed schema, and every document can be different, how do you index it, right? And the answer to that is, it depends, right? Square. Yay! It depends on what database you're using. Okay, so let's take two examples just to show you the two methods of doing it. So if we take RavenDB, for example, what happens in RavenDB is you create a link statement, okay, which will project things that match your link statement into objects, okay? And that link statement is run in the background, so it runs continuously. So whenever you want, let's say, every customer document where the customer's name is Gary Short, okay, that's the link statement you execute. Okay, you execute that link statement. It uses, behind the scenes, it uses the Lucene text search engine to actually parse all the text and find those, all right, but you don't have to worry about that. You execute that link statement and back comes the matching criteria, okay? And you can do grouping by using the grouping statement within the link, all right? Now for CouchDB, which runs mainly in the Linux world, okay, they use a different method. They use a map reduce method, okay? So what they do first of all is they map every document in that database to a particular function, and that function will filter out ones that match, okay? And that's the map. So now we've gone from all of the documents down to a finite amount. And sometimes that's all you require. You just wanted to filter, and it will return that. Other times you want to do grouping and aggregates and things like that as well. And what you do in that case is you write a reduce function in JavaScript, and that actually takes lots of data and then aggregates it into some points, okay, and then returns those. All right. So the answer is it can be. The important thing to know is it can be indexed. It just depends on which NoSQL database that you're using on how that actually happens. Okay. Okay, now we really have to start moving. Let's compare some real-world scenarios. All right, so let's say you need constant consistency. All right, there's no such term. I just made that up, right, just to differentiate it from eventual consistency. So let's say you need your database to be consistent. If you're dealing with financial transactions or you're dealing with medical records, okay, if I'm going to have my leg amputated, right, and my record states I've got to get my leg amputated, my left leg amputated, it sure as God made little green apples better say the left leg by the time I get down to the operating theatre, right, and he's looking on the database then, okay? You can't just go, nah, I'm not too sure, we're not really consistent yet. He says he's got to get something amputated. Let's just start hacking away until that database updates, right? That is a bad place to be, okay? Or if you're dealing with bonded goods, goods which you require to pay tax on immediately, all right, you need to be consistent. In those situations, okay, best to use a relational database management system. Now, that's not to say there are not NoSQL databases which are not consistently consistent, okay? There are, it's just that there's nothing in there that's outside the world of a relational database model, all right? So that problem's already solved using relational databases, so why move to something else and make your life more complicated than it needs to be, all right? So in those circumstances, by all means, use an RDBMS. I can't believe I spelled RDBMS wrong. How impressive is that? It's not even a word, it's just a set of initials, and I've transposed those two. Never mind. But let's say you need horizontal scalability. Okay, so you're working across defined geographic regions where you say this is Africa, this is Europe. Okay, you can have them in different databases, or you're working with large quantities of data. Okay, so you're doing horizontal partitioning of large data. All right, or you're doing game server sharding as another reason. Okay, use NoSQL for that. All right, that is brilliant. Something like Cassandra will be really good for that. Again, that is not to say that you cannot do horizontal scaling using SQL Server. Who's done that kind of thing with SQL Server where you've had partitioned out and you've got, yeah, was it fun? No, that's the difference, right? It's hard. It's hard work doing that. These new databases make things like horizontal scaling and things like that easy, okay, or easier. So, up in the clouds, baby. Who uses Azure or Amazon Web Services here? All right, excellent. Who uses table storage versus SQL Azure? So who uses table storage? Okay, hands down, who uses SQL Azure? All right, a few people. If you're using SQL Azure, that's costing you a lot more money. It's costing you a lot more money than table storage. So you should think to yourself, can I get away with using table storage? Can I use the NoSQL equivalent? All right, and if you can, same if you're on Amazon Web Services, all right, SimpleDB is much cheaper than the SQL equivalent. Okay, think to yourself, can I get away with just using SimpleDB or table storage? And if so, use it, it's cheaper. What about the Windows Phone 7? All right, the issue there with using databases is that's a constrained device. Okay, you can't just put in more memory, right? You can't say, oh, the SQL that I've got on my phone database is not big enough, I'm just going to put it in another disk, right? You can't do that. So you have to think to yourself, can I get away with using some NoSQL strategies here? Can I get away with just straight serializing my objects to text? Do I really need some form of proper database, okay, on my constrained devices? Not just Windows Phone 7, but any kind of small constrained device. Really think hard about, do I need to put a database on this machine? Frequently written, rarely read. So things like web counters and the like. Okay, so every time a user comes to a page, the counter gets incremented, but it's only ever read when the report gets run to see how many people. Now you might only run that report once a quarter or once a year. Okay, and yet it's updated every time somebody comes to that page. All right, key value storage, something like Memcache is perfect for that kind of thing. You don't need a full-blown database to do that. What happens if you've got big data, right? And by big data, I mean weather maps, satellite imagery, mapping in general, geographical mapping, not just weather maps and things like that. Huge amounts of data that you're trying to deal with, all right? NoSQL databases are excellent for that. Things like Hadoop, for example, are perfect for that. And they're designed for doing that kind of thing where SQL Server and Oracle and things like that are not really. Binary data. So if you're YouTube, if you're Flickr, or your TwitPic, or your Spotify, all right? Binary data, you don't save anything by storing binary data in a database, right? You can only store that as a blob, right? There's no record that describes a video, okay? So if that's what you're doing, then Amazon S3, some kind of NoSQL equivalent is excellent. You'll notice that kind of thing, but you can find Twitter, for example. Those of you who've got Twitter, put your hands up if you've got an avatar, your own picture as your Twitter account. The next time you load somebody's page or your own page, have a look at the URL at the bottom of your browser as it's loading, and you'll see all of those images are actually stored in Amazon S3 storage to a great advantage. So let's have a look at Twitter. What challenges does Twitter face? All right, they need to store many graphs. We already spoke about what graphs are. Okay, so they have graph storage problems. All right, they need to know things like who you're following, who follows you, who you receive telephone notifications from, that kind of thing, all right? To deliver a tweet requires a rapid paging of followers, all right? There's a heavy write load as followers are added and removed, okay? It needs great set arithmetic, okay, for the at mentions, for the intersections of the users. Because if you at mention somebody, there's a complicated set of rules of who actually sees that depending on who follows who in the conversation, okay? It requires set arithmetic, the intersections, to work out who gets to see that. Okay? So, what did they try first of all? So first of all, they tried relational databases. Okay? And then they tried key value storage of denormalized lists. All right? Denormalized means we don't have the relational problem, all right? We don't have to do joins or anything like that. Okay? So, did it work? Nah, not so much. All right? Those of you who use Twitter who've seen that ever? Okay, yeah, pretty much everybody has seen the fail whale, right? Which is a great concept in and of itself, all right? The fail whale. So no, really, it didn't really work. So, the good guys at Twitter, they sat down and they thought to themselves, right, this isn't working, we need to design something ourselves or we're going to go out of business. Our servers cannot keep crashing like this. So they sat down and they said, so what do we actually need? Well, we need the simplest possible things that would work. Why do we need the simplest possible thing that would work? All right, here's why. If you've got a complicated problem, and I would suggest that running the data management for Twitter is a complex problem, the last thing you want is a complex solution, all right? Because we only have a finite amount of intelligence. If you're somebody like me, that's quite a small amount, all right? But we only have a finite amount of intelligence, and if you've got a complicated problem, that uses quite a lot of your brain power just to understand the problem, and then if the solution is going to be complicated on top of that, right, you get to the stage where you just go, do you know what, I don't understand what it is I need to do here, all right? So what we want is the simplest possible thing that would work. We want to allow for horizontal partitioning, obviously, because we need to scale out really quickly as the numbers of people joining Twitter grow. All right? We need to allow write operations, and they need to arrive out of order. Okay, and I'm going to speak a bit more about that later. And they need to be able to be processed more than once. All right, and I'll speak a bit more about that later as well. And failures should result in redundant work, not lost work. Okay, so what that means is, if you have a failure, don't give up, right? Try this, no, it failed, right? Okay, I'm not going to do it anymore, I've lost some data. Try this, oh, it didn't work, try it again, oh, it didn't work, try it again, yes, it's worked, oh, try it again, I told you it worked already, try it one more time, yes, it's worked already, for goodness sake, all right? That's redundant work, all right? Redundant work is much more preferred to lost data, okay? So, and the result they came up with was FlockDB. Who's heard of FlockDB? All right, since I mentioned it in one of my slides, I'd expect everybody's hand to be up, right? So it was a bit of a test, right? So you guys are clearly not paying attention, all right? I can't pretend I'm a bit disappointed to people, but I'm not angry, okay? I'm just a little bit disappointed with you, okay? So, FlockDB stores graph data, all right? It's not optimized for graph transversal operations. I read that and I went, pardon? It's not optimized for graph transversal, all right? It's a graph storage database, and it's not optimized for graph transversal, easy for me to say, I'm going to give up that word, all right? That word. It's not optimized for that, okay? There are two great reasons why it's not optimized for that. Can anybody give me any of them? Doesn't make any difference. You said that's brilliant. You don't need to do graph storage, right? You don't need to transverse the graph, it turns out, right? You don't really care if you're connected to you, connected to you, connected to you. What you really need to know is, what are the group of people, what is the intersection of the set of people who follow me with the set of people that I follow, okay? And when you realize that, you think, oh my God, of course, that's why it's not optimized. Twitter does not need it to be. And the other option is, it's really hard. Who did asymptotics at school and at university, and who did algorithms at university? All right, graph transversal is one of these NP-complete problems that basically you can run it to the end of time. There's no fast way to do it. You have to check every single one, all right, and then find the best one, all right? So that's one reason. One, it's an NP-complete problem, and that's a millennium, one of the millennium puzzles. If anybody here has solved NP-completeness, all right, please come and tell me. Together we will make a fortune, all right? People at Twitter haven't done it. But the reason is that they don't need to, it turns out. So, it is optimized for large adjacency lists. What are these? Well, they are a list of all of the edges in the graph. Remember, the edges are the lines, okay? Each entry is a set of endpoints, or it's a tuple with a start point and an endpoint if the graph is directed. Otherwise, it's just a set of endpoints. So it's keyed on the edge, and the values are all of the endpoints for that edge. Okay? It's optimized for fast read and write. That's what Twitter needs. And it's optimized for pageable set arithmetic. So if I say, what is the intersection between people who follow me and people who I follow? If that is like millions of people, okay, then you need to be able to page that. So how does it work? It works very well, thank you. So it stores graphs as a set of edges between the nodes. All right? The data is then partitioned by node. Right? So the data is partitioned per person. That is brilliant, because every piece of information that I need to know about that person is on one partition. I don't have to move anywhere. All right? I've got it all to hand once I know the partition. Brilliant idea. All right? Thank you very much. I just said that. The write operations are, and this is I always have problems pronouncing this, idempotent. Okay? What that means is they can be applied multiple times without changing the result. All right? Remember, we already said failures should result in redundant work and not lost data, okay? So this is why they are all idempotent, because they can be run multiple times without changing the result, okay? And they are commutative, okay? That means changing the order of the operands doesn't change the result, okay? So let's have a look at what that actually means. So a little bit more about idempotency. Applied several times with no change to the result. So here's the official Wikipedia definition, if anybody's interested. I'm not that interested. But what it says is, if an operation O on a set S is idempotent if for all x's in the S, XO, x equals x. Yeah, I read that and I went, what? Some mathematician, you know a mathematician wrote that, right? And I thought, yeah, okay, but what does that actually mean, right? So what it actually means is, if you think of a set union, right? A is a union with B, okay, then every time you union set A and set B, if nothing changes, you get the same result, right? It doesn't matter how many times you do it, you're going to get the same result, all right? Intersection is another one, okay? A intersects B if A is in E, A is in, X is in A and B, okay? Again, if you don't change either of the sets, every single time you ask for the intersection, you'll get exactly the same results back, okay? No matter how many times you ask for that. Okay, let's talk a little bit more about commutative. Changing the order of operands doesn't change the results. This is actually dead simple to understand, okay? Even I can understand it because it's as simple as this, right? What it means is 3 plus 2 equals 5, change the order, 2 plus 3 is the same, right? And that's all it meant, all right? And I saw that little thing and I thought, ha, cool, I understand that now, all right? You can combine the two together, all right? So let's look at the follow command in Twitter. let's assume that letter X is going to be follow person X. Okay, so if I say let Y equals follow person Y, then if I follow X 3 times and I follow Y twice, that's exactly the same as saying I want to follow person Y twice and person X 3 times, right? I get the same result. The result is I followed person X, I followed person Y. Okay? It's exactly the same here again. Those 2 things are again exactly the same. All right? But note, it's only true for the same operation. All right? It's only true if you're doing a follow. So it doesn't matter if I follow one person 3 times and follow another person 2 times and change that around, I get the same result. But if I start to mix operations, it doesn't hold true. So if I'm doing follows and unfollows, if I mix those up, depending on which one I end with, I'll get a different result. Okay, so remember, it only works with the same operation. So why that's important is commutative rights help us to bring up partitions really quickly. And this is how. All right? So a partition can receive write traffic immediately. As soon as you bring up a new machine, new partition, right, it can receive write traffic immediately because all you're doing is storing it. All right? You're going store this, store this, store this. In the background, it can receive a dump of data that you're actually wanting to put onto this partition, right? And it doesn't matter if that partition has one of the... Ooh. Spooky. Guy, hasn't it gone quiet? And it was like, my God. Okay, so it doesn't matter if some of the operations in that in the data dump are duplicated in the reads that it's receiving, because we've already said it doesn't matter if you do the same thing twice, you get the same result. Okay, so that's why you can bring it up really quickly, and it can be live for read as soon as that data dump is complete. All right, so as soon as that data dump is down, right, you can read from your partition, and that ability creates the ability to bring up partitions really quickly. So performance, what is the performance like? Did it work? Well, Twitter currently stores 13 billion edges, it has 20,000 writes per second and 100,000 reads per second. So I would say yes, it does. Anybody work in an application that has that kind of performance? Needs that kind of? No. Yeah, me neither, to be honest. All right, but I would say 100,000 reads per second and 20,000 writes per second, yeah, they've pretty much cracked the performance thing, all right? But what's the punchline? What is the punchline to all this? Remember I said back at the start or near the start that NoSQL didn't stand for NoSQL, it stood for not only. The punchline is, under all those bells and whistles, it's just MySQL, right? It's built on top of MySQL, all right? So we're getting down to that not only SQL, all right? Okay, under the hood, relational database under FlockDB. So is it the future then? Well, yes, it absolutely is the future, and no, it absolutely is not the future. Yes, ladies and gentlemen, if there's a fence big enough, I will sit on it. So, how can that be? How can I see these things? Well, I'm not entirely sure this is going to stands up in the UK, but I'm going to try to explain it in terms of political parties. Oh, holy moly. Is that rain? Wow. So in the UK, we have this thing called the Green Party, right? We have 2 main political parties, right? The Conservatives and Labour. But the NoSQL is a bit like the Green Party in British politics, okay? Nobody really wants them in power because some of their policies are way out there, all right? But the main political parties are scared of them because some of the things they talk about are really, really cool, right? And they're scared that people will either drift away to those parties or the opposition will start to implement some of those policies, okay? And so the same is exactly the same. And what happens there is the 2 main parties, the Conservatives and the Labour Party, tend to start to implement green policies, right? Just so that they don't lose voters to the Green Party. NoSQL is going to be like this, okay? So down here we have Microsoft, okay? Down here we have Oracle, all right? Up here we have NoSQL, all right? The guys, right, at Microsoft and at Oracle can only hear the phrase, all right, we can't build the next billion-dollar company on relational database systems so many times before they start saying to themselves, guys, if we want to be involved in the next £1 billion or billion-dollar companies, we need to start supporting these NoSQL practices, all right? So that's why it is the future. In and of itself, I don't think this time next year we'll all be using CouchDB or MongoDB. I don't think we're going to spread, we're going to move wholesale to those. But what I do think is you're going to start to see a lot more of the philosophies of NoSQL starting to arrive in these big companies' database management systems. A good example of that is it's not Twitter. A good example of that is Trinity. Right? Trinity is a brand new graph storage database using the NoSQL model from Microsoft. Now, at the moment, it's just in the research lab. So if you go to research.microsoft.com, you can read all about Trinity. So Microsoft is already getting on the bandwagon for NoSQL. So that's why I say it is the future. And with that, I've got about 4 minutes for questions. If you don't have time for your question, please feel free to track me down at the Dev Express booth downstairs. Or if you don't want to come and do that, then please feel free to write to me or send me a tweet. But with that, does anybody have any questions about what I've said today?
When you talked about data partitioning, what exactly you moving the data away from one server to
No. So, well, yes, but what I mean by data partitioning is this. Let's say we have all of our customers, right? We start a database and we've got one table and it's called customers, okay? And it grows and it grows and it grows and it grows until we get to the extent where we can't have just one table for customers anymore. What do? Well, what we do is we take a binary chop, right? We say what's halfway, so A to M and then N to Z. And we take that. And what we do is we move that, the top half onto one server and the top half onto another server. And if that's still too much, then we do another binary chop and we move those to other servers. And we keep doing that binary chop and moving to different servers until we get the performance we're looking for. Okay? And that's what I mean by partitioning. And this is what things like CouchDB are particularly good at doing. You can do it in SQL Server as well. All right? I'm not saying you can't. What I'm saying is it's easier to do in CouchDB.
Yeah. But similar concept came
There you are.
similar concept came where we started using the XML kind of thing where things were tagged and
Yeah.
is it similar to that?
Yes, similar to that kind of thing. Yeah. Oh yes. So Mehul's just reminded me that he's told me I have to give away a coder's license. Who was in Mark Miller's keynote this morning and saw some of that stuff that he was doing? All right. So we've got a product that kind of encapsulates that. So we're going to give away that coder's license. Since it was Mehul's idea, Mehul's going to come up with a question right now.
In the session, he talked about the mouse is going to die as a thing. So when did he say? How many years is that going to take?
25.
Okay, this is going to be much tougher. Let me get, I'll ask you a follow-up question.
Right, so this time, let's do it this way, right? Put your hands up and we'll look to see whose hand was up fastest, right? Right, you ask your next question then.
Okay. What was one of the innovative features before 1981 for the IDE? Okay, you're the winner.
That was excellent. So if you speak to Mehul at the end, he'll sort you out with your coder's license, okay? So I think I've got a couple more minutes. I'll maybe take one more question now. Nope. Yes, sir.
In your RDBMS, how you partition is you, in terms of scalability / availability, you maintain a clustered environment versus a master slave kind of setup. How do I do it on no slave where it's a node which have a heartbeat kind of stuff in terms of replication? So how do I achieve that?
So you achieve, right, the question was, how do I achieve, why is it easier on something like CouchDB and something like that? So basically, it's easier because all you really do is you tell CouchDB to create another partition. It does that for you, right? And you say, this IP address is now part of the partitions that I want you to manage, right? And it's all handled for you, right? So it's much, much simpler. Okay, guys, I think we're out of time now, so if anybody's got any more questions, please see me at the DevX booth. And apart from that, thank you very much for coming along and listening to me today. Thank you.